Welcome to Geometry Lesson 9.1, Translations. Our objective for today is that students will be able to identify isometries and find translation images of figures. So the first thing you need to know is that you can change the position of a figure without changing its size or shape. A transformation of a figure changes the position, shape, or size of the figure. One great example is when you play dominoes. When you draw a domino, you flip it over, and you've changed the position of the figure. If you slide it down so you can play it on the board, you've changed the position. You moved it from one place to another. And sometimes you need to turn your dominoes to make them for different things, and that's also changing the position of your object. Now, in a transformation, we have two things. We have the pre-image and we have the image. The pre-image is the original orientation of the object, the original object. So here would be our pre-image, and here would be our image. An isometry is a special type of transformation in which the pre-image and the image are congruent. So an isometry is something where if you look at the pre-image and the image, they're congruent. And remember, congruent means the same. Now, if we look at these first two, it says, for each transformation does it appear to be an isometry. Now remember, an isometry doesn't change the size of an object. They are congruent. So we're looking at this pre-image and this image. The pre-image is smaller than the image, so this one, no, they're not the same size. These would be similar, but they're not congruent. You could even say congruent is something they are not. This pre-image and this image, well, what they did was they reflected along this line right here. We'll talk about reflections, but these two shapes here, they are congruent. You haven't changed the size of the figure. If I scroll down, here's another one, pre-image and image. These two, they've been reflected and slid along that line, but the size of those two objects has not changed. Those two objects would still be congruent. Yes, we have an isometry. We also have an isometry. Yes, an isometry on that one. So, we've talked about isometries a little bit and transformations. Now, what a transformation does is it maps a figure onto its image, and you can describe it with arrows, and such as the arrows in this picture. See those three arrows? They've shown how it's done. Here you see another arrow. They say you take the first figure and you map it to the second figure. Now notice they have these little, they look like apostrophe signs. They're called prime notation. We use those to identify the image points. So if you see a point J over here and a point J over here, the first J that doesn't have the apostrophe, that's the original. Oh, sorry. That would be our original figure, our original J, and this one is going to be our image. This is where J is mapped to. So get in the habit of writing that whenever you draw a figure and you draw its image and its pre-image. The image where it's being mapped to should always have those prime notation on it. Now, since if you have an isometry, the image and the pre-image are congruent, we can use that to find some of these matching parts. So here we have EFGH is mapped to EFG, E prime, F prime, G prime, H prime. So it's been translated over. Now, if you notice, F is the second letter. So if we're trying to find the image of angle F, well, you look at the second letter in the image. In the pre-image, the image F is going to F prime, so angle F would go to angle F prime. And the same thing would happen for angle H. It's going to go to angle H prime. Now the question is, what are the pairs of corresponding sides? Well, in the first image, we have FE. Those are the first two letters. That's going to correspond over to F prime, E prime. So FE segment, it's going to go to F prime, E prime segment. If you look at the now, FG is going to go to F prime, G prime. FG maps to F prime, G prime. My computer screen's going crazy on me. Sorry about that, guys. All right, then GH goes to G prime, H prime. And last but not least, EH goes to E prime H prime. So you can use the statement down here to line up some of those corresponding parts. You can also look in the figure what lines up with what. If they've been named with prime notation, it's really easy. If they haven't been named with prime notation, you're going to have to pay attention to your statement and the order that things are in. So here we have another essential understanding that the size, shape, and orientation of a geometric figure stay the same when you slide the figure in one direction. So one of our big transformations is called translations. And a translation, no, you're not changing from one language to another. You're just taking an object and you're sliding it over. So this B right here, we slid it over to B prime. A slid over to A prime, and C slid over to C prime. Now notice that A, B, C and A prime, B prime, C prime are the same size, and each one of those points slid over the same amount. Okay? A translation is an isometry, so it preserves size. So those two shapes are going to be congruent. Now, the big place where we see translation is in the coordinate plane. In the coordinate plane, you can say that each ordered pair is mapped to another ordered pair. So you can take x, y, and map them to x prime, y prime. If you move a shape right 4 and down 2, you use this arrow notation to notate that. If it's moving right 4, remember, horizontal is x, vertical is y. So if it's moving right 4, x has been increased by 4. If it's moving down 2, y has been decreased by 2. So you're taking a point that's maybe up here and you're moving it right 4, down 2, so your final point would be right there. Let's take a look at some of that notation in the plane. So it says, find the image of a translation. What are the images of the vertices of triangle PQR for the translation XY maps to x minus 2, y minus 5? I find that when we have something like this, it's easiest to identify what's it doing. So if it's moving x back to that negative 2, we're going to go left 2. And if it's moving y negative 5, that's down 5. So we're going to take each point of PQR and do that to it. We're going to let's start with R. R is going to go left 2 and then down 5. It's going to end up right here. Now when we name it now, since it's now in the image, we're going from pre-image to image, it's now R prime. We're going to do the same thing with Q, move it left 2 and then down 5. Now it's Q prime. Do the same thing with P, left 2, down 5. That's now P prime. Don't forget to connect your dots. And there you've translated an image. Questions so far? If you have a question, pause the video, talk to somebody in your group. Here's the next one. It says, what is a rule that describes a translation? Now, when we describe this translation, what I would do is I'd go into the graph and I'm going to go from a pre-image to its image. So P goes to P prime. So to get over, I'll go all the way over and down. Once I have that written on my paper, I count it out. It's going in the x direction, x-axis, horizontal, 1, 2, 3, 4, 5, 6, 7, 8. I'm increasing it by 8. I added 8 to it. And then to go down, then to get to P prime, I still had to go in the vertical direction, down 2. Now, if you remember, x is horizontal and y is vertical, so that means that I'm taking the x and it horizontally moved 8, so I'm adding 8. And I'm taking the y, because that was the vertical value, and it went down 2, so I'm subtracting 2. What I want you guys to do now is to pause the video and translate this object and come up with the rule for the translation. Now check your work with mine. I graphed the new points and then I noticed I used M. You could use any point you wanted to, but M I had to go over 7 and down 1. Since 7 is the horizontal value, I'm changing the horizontal value with that. Since negative 1 was the vertical value, I'm changing the vertical values. All right, last example. So the next thing we need to talk about is a composition of transformations. What that is a combination of 2 or more transformations. If you have a composition, you perform each transformation on the image of the preceding transformation. So if we're looking in this picture over here of these hockey players, field hockey players, the translation is the puck is going from number 3 to number 9 and then from number 9 to number 5. And it's taking that path, but really the change in its position is it just went from 3 to 5. Now, for some reason, they didn't pass it from 3 to 5. They passed it to 9 first. So, the two red arrows show the composition that's occurring, and the blue arrow tells you what in total has occurred. So if we're looking now at this diagram right here, chess, it says the diagram at the right shows two moves of the black bishop in a chess game. Now, if you know anything about chess, bishops can only move diagonally. So your bishop is starting right here. It's kind of in the shade. And it's moved diagonally to this box, and then it's moved diagonally to that box. So the question is, where is the bishop in relation to its original position? We do this, we want to look at each transformation on its own and then compose it all together. So this first one to get from here to here, we look at what's occurring. Well, the bishop is going over 4, down, over 1, 2, 3, 4, yep, down 4. So over 4, down 4. So the first one is going to go x plus 4 because the horizontal change is plus 4. And then y minus 4 because the vertical change is down 4. Now, the bishop didn't finish moving. It went from its new location and it moved all the way over to this location. And we also want to look at what is that translation. So in this translation, we look at the horizontal first. It's going over 2, up 2. It's increasing the x by 2, increasing the y by 2. So when we look at our way of notating that, we're going to say x plus 2, y plus 2. Now, if we go back to the question, it says relation to its original position. So what you want to do now is, if you know the two translations that are occurring, you want to combine those two. So in total, it's moving plus 4 plus 2. Well, 4 plus 2 becomes 6. The x is changing by 6. Look at your y values now. Minus 4 or a negative 4 plus 2. That makes a negative 2. So in general, y is going down 2. And so that would be your composition. That would be the position of the bishop in relation to where it originally started. So from its beginning to its end point, if you were just counting that, it's going to go over 6, down 2. All right, well, that is the end of this lesson. Remember, the objective was to be able to identify isometries and find translation images of figure. Make sure to pause and write something about what you learned today in your objective, about 2 sentences, and then rate yourself on a scale from 0 to 4.